It's pretty wild when you think about it. In 2024 alone, over 1,500 research papers with keywords related to AI alignment were uploaded to ArcSef.
1,500.
I know, right? It just goes to show you how many brilliant minds are grappling with this huge question. How do we make sure these AI system, the ones that are getting smarter all the time, how do we make sure they actually do what we humans want? Have you ever really thought about what it means to align AI with human values and why it's such a hot topic?
It's a massive challenge, that's for sure.
Totally.
And the sheer volume of research just highlights how important it is.
Absolutely.
At its core, AI alignment is all about making sure that as AI gets more powerful, its goals, its actions, they stay in sync with what we want as humans.
Right. We don't want them going off and doing their own thing.
Exactly.
So that's what we're diving into today.
Getting into the nitty-gritty.
Exactly. We're exploring this fascinating idea. Well, it actually challenges a pretty common assumption. Yeah. It's the idea that we can align AI just by having it observe how humans behave.
That makes sense on the surface.
It does.
Show AI how we act, and it'll pick up our values.
Exactly. But the sources we're looking at today, especially this paper, statisticalcase.pdf, they make a really compelling case that this approach, as obvious as it seems, is actually full of potential problems.
Like what? Hidden biases.
Yeah, exactly. And our goal today is to understand why this isn't always the best way to go about it and to look at some alternatives that people are proposing.
Okay, so let's break it down.
For sure.
This idea of AI learning by washing us, that's actually the foundation of a lot of current AI alignment work.
Really?
Oh, yeah. It's called empirical human AI alignment.
Empirical, okay.
Basically, it means training AI systems to copy or to try to optimize for things that they see humans doing and the preferences they observe in us.
So kind of like learning by example, but on a massive scale.
That's a great way to put it.
Okay.
It's got that intuitive appeal, like you said. We learn languages by immersing ourselves, right?
Yeah.
But this statistical case paper, it brings up a super important point, especially when you look at it from a statistical angle.
Okay.
It argues that even though the goal, aligned AI is a good one, this empirical method could accidentally introduce all sorts of biases. And there's this quote from way back in 1960 by Norbert Wiener that the paper highlights. He says, "We had better be quite sure that the purpose put into the machine is the purpose which we really desire and not merely a colorful imitation of it."
Wow.
Right. It really gets to the heart of the issue.
Totally. It's are we really teaching the AI what we value, or is it just mimicking us without really understanding?
Exactly. And the paper goes deeper into different types of empirical alignment.
Oh, there are different types.
Yeah. So there's forward empirical alignment, where the AI is aligned during training before it's actually deployed.
Okay, so that's setting it up with good values from the start.
Exactly. Then there's backward empirical alignment, which happens after the AI is already out there in the world.
So you're tweaking it based on how it's acting.
Yeah, like course correcting.
Got it.
And then they talk about prescriptive alignment, which is giving the AI rules or principles, not just observations.
Okay, so setting some ground rules instead of just showing examples.
Precisely. This specific paper really zeroes in on the potential dangers of forward empirical alignment, trying to bake in our values just by showing the AI what we do before it's even fully operational.
Interesting. So let's dive a bit deeper into that. The paper's main argument is that just observing humans isn't enough to properly align AI. What are some of the issues with this strategy?
Okay, so one major issue they point out is anthropocentric bias.
Anthropocentric bias. Okay, I've heard that term before, but remind me.
So anthropocentrism is this idea that humans are at the center of everything.
We're the most important thing.
Yeah, or even the only thing that really matters.
Right.
And historically, this has been a big influence on how we think about science. The paper even mentions how way back in the 12th century, Moses Maimonides, a super influential philosopher, argued against this human-centric view.
Wow, that long ago.
Yeah, he emphasized how vast the universe is and how, relatively speaking, humans are just a tiny part of it.
That puts things in perspective.
Right. So how does all of this connect to AI alignment?
Yeah, that's what I'm wondering.
Well, the paper uses this analogy. Just like focusing only on what humans can directly observe in the universe might make us miss all sorts of other things that are out there. Aligning AI only with human preferences, based on how we act, could make the AI overlook stuff that's important, but beyond our immediate grasp.
Oh, I see what you mean.
There's this quote from Peters in 2012 that sums it up nicely. "Nature has much more structure than what is useful for humans."
So basically, we might be limiting the AI's understanding by only showing it things from our limited human perspective.
Exactly. Think of it like assuming that everyone loves your favorite food just because you love it. It's a very human way of thinking, but it can lead to a pretty narrow view.
Totally. It's like, just because I like pineapple on pizza doesn't mean everyone else does.
Exactly.
Okay, so our own human biases could create blind spots for the AI.
Exactly. And this ties into another concept from physics. Yeah. The anthropic principle.
Ooh, physics.
Yeah, so the anthropic principle basically says that what we observe about the universe is limited by the fact that we're here to observe it in the first place.
So, like, we can only see the things that allow us to exist to see them.
You got it.
Whoa, that's trippy.
Right.
But how does this relate to AI?
Well, the paper links this to AI alignment through Bostrom's idea of the self-sampling assumption.
Self-sampling assumption, okay.
Imagine we're training an AI using data on human behavior, to try to teach it what's important.
Okay.
We need to define the reference class, which basically means deciding which kinds of situations or environments are relevant.
Right, like what kind of data are we using?
Exactly. If we make that reference class really broad, like including all possible AI environments, then our little sample of human behavior becomes just one tiny data point in this huge space.
Oh, I see.
And it might not be representative at all.
Yeah.
On the other hand, if we only focus on situations directly related to humans, the AI might not be able to generalize to new situations, ones that aren't so human-centric.
Right, like it's only seen the human world, so it wouldn't know how to act in other contexts.
Precisely. The crucial point is, if we don't make any specific assumptions about where our data is coming from, the overall population, we're implicitly assuming that our limited sample of human behavior is enough for the AI to figure everything out.
Yeah.
And like the anthropic principle suggests, that's a pretty risky assumption.
So just relying on what we observe might not be enough.
Right. It's like trying to understand the whole ocean just by studying a few puddles on the beach.
That's a good analogy.
It inherently limits what we can teach the AI.
Okay, I'm starting to get the picture. So the paper's title mentions a statistical case against this kind of empirical alignment. Can you unpack that for us?
Sure. This is really the core of their argument. The problem is that when we try to align AI with a whole population of humans based just on a sample of what we do, that sample might be messed up in all sorts of ways.
Like, it might not be a fair representation of how humans actually behave.
Exactly. They talk about this concept called total survey error, or TSE, from a book by Groves and Leiberg.
Total survey error. Okay, tell me more.
So TSE basically breaks down all the different ways that our data can be biased.
Okay.
They separate it into population representation biases and structural representation biases.
Okay, so two main types of bias.
Right. Population biases happen when the sample of humans we're using doesn't accurately reflect the whole group we're trying to align the AI with.
Like if you only surveyed people in one city but wanted the AI to understand the preferences of the whole country.
Exactly. That's a classic example of a biased selection frame. It means you're not even drawing your sample from the right group of people to begin with.
Oh, I see.
Then there's sampling error, which is just the random variation you get when you take any sample.
Yeah, like even a fair sample won't be perfectly representative.
Right. And then there's non-response bias.
Right.
That's when certain types of people are less likely to participate in your data collection.
And their opinions might be systematically different from those who do participate.
Exactly. So if the data we use to train AI is missing input from certain groups, the AI is going to be less aligned with your understanding of fairness and representation.
Right, because it's not getting the full picture.
Exactly.
Okay, so even before we start training the AI, our data might already be skewed.
Exactly. And then there are structural representation biases, which are about how we gather and interpret the data itself.
Okay.
This includes biases in how we define complex ideas, like how do you actually measure something like fairness or well-being.
Right, those are hard to quantify.
Totally. Then there's item non-response, which is when people skip over certain questions.
Yeah, I've done that on surveys before.
We all have. And then there's omitted variable bias, which means we might be missing important factors that actually influence behavior.
Like what?
Oh, it could be all sorts of things. Maybe we don't have data on people's socioeconomic backgrounds or their cultural influences, or maybe we just don't have access to certain information because of privacy concerns.
Right, so there might be important context that's missing.
Exactly. And the key takeaway here is that, except for random sampling error, these biases, these big data biases, they don't just disappear when you have more data.
Oh, so more data doesn't automatically solve the problem.
No. It's like having a bigger bucket of seawater that's still only coming from the same biased puddle on the beach.
That's a good point.
A bias sample is still a bias sample no matter how big it is.
Okay, that makes sense. More data doesn't necessarily mean better data.
Exactly. The paper also talks about something called selective inference.
Okay, what's that?
This is where biases sneak in, because we choose our AI models or even specific features based on the same data that we're using for alignment.
So it's like we're setting the goalposts based on how the game is already being played.
Perfect analogy. It can be a big problem if our targets for alignment, what we want the AI to achieve, are based on this same potentially manipulated data.
Right. It's like we're rigging the system to make it look like the AI is aligned when it might not be.
Exactly. And then there's this really interesting challenge called the reflexivity problem.
Reflexivity? What's that?
It basically means that humans, we change our behavior when we know we're being watched.
Oh, yeah, like the Hawthorne effect.
Exactly. So if people know they're being observed to train an AI, their behavior might not be natural anymore, which messes up the whole point of trying to learn from their preferences.
Right, because the AI is learning from a distorted version of human behavior.
Exactly. The paper uses the example of reinforcement learning from human feedback, or RLHF, which often assumes that our preferences stay the same over time.
Right, but our preferences can change, especially as we interact with AI systems more.
Exactly. Some researchers even think that AI might eventually change our intentions themselves.
Wow, that's kind of mind-blowing.
Right. It's a pretty complex issue.
But couldn't you argue that even if people know they're being watched, their fundamental tendencies might still come through in their actions? Like, wouldn't that give us some genuine signal amidst all the noise?
That's a really sharp observation. You're right that core tendencies might still be there, but the way they're expressed can definitely be affected by the fact that someone's being observed.
Oh, okay.
It adds another layer of complexity that pure observation struggles to account for.
So it's like we're trying to understand someone's natural behavior, but they're putting on a performance because they know they're on camera.
Exactly, like putting on your best behavior for a job interview.
I get it. So even with that genuine signal, there's still a lot of noise to filter out.
Right. And the paper mentions another issue called causal misrepresentation.
Causal misrepresentation. Another new term. Break it down.
This is where we see correlations in the data that don't actually reflect a true cause and effect relationship.
So it's like confusing correlation with causation.
Exactly. Just because two things happen together doesn't mean one caused the other.
Right.
The paper's overall message is that while statistics can help us deal with some of these biases, those tools often involve making extra assumptions about humans, like prescriptive elements.
Prescriptive elements. Okay.
And they argue that we should be much more upfront and honest about those assumptions.
So instead of pretending our data is perfect, we need to acknowledge its limitations.
Precisely.
Okay, so if relying just on observing human behavior is so problematic, what are some of the alternatives?
Well, they really push for something called prescriptive human AI alignment.
Prescriptive, okay. What does that involve?
Instead of just looking at what humans do, we use predefined rules or principles as the target for alignment.
So we're like setting the standard in advance instead of letting the AI figure it out from observation.
Exactly. Think about something like figuring out people's preferences.
Okay.
It's usually easier to get people to agree on rational principles about preferences.
Like what?
Well, for example, if you prefer option A over option B, and you prefer option B over option C, then logically, you should prefer option A over option C.
Yeah, that makes sense.
That's called transitivity.
Transitivity, got it.
But the funny thing is, as the paper points out, people don't always act in a way that's transitive, even if they agree with the logic.
So we're better at agreeing on the ideal than actually living up to it.
Exactly. A prescriptive approach can actually help prevent those irrational patterns by design.
Oh, how so?
For example, instead of asking people about every single possible choice, you could use that transitivity rule to infer some preferences.
So you're like filling in the gaps based on a logical principle.
Right. It helps ensure a more consistent outcome.
Okay, that's interesting.
They also talk about preference aggregation.
Preference aggregation.
It's about how we combine the preferences of many different people.
Right, because everyone has different likes and dislikes.
Exactly. And there's a famous theorem called Arrow's impossibility theorem.
Sounds complicated.
It basically shows that it's really hard to combine diverse preferences in a way that satisfies a few basic fairness criteria.
So, like, there's no perfect way to make everyone happy.
It's more nuanced than that.
Okay.
It's about the limitations of any system that tries to aggregate preferences.
Right.
But a prescriptive approach might be able to sidestep some of these issues.
How so?
Well, Instead of being strictly tied to what individuals say they prefer, it could potentially use other information, like how strongly someone feels about a preference.
Oh, so it's not just about counting votes, but about weighting them based on how much people care.
Exactly. That's a much richer way to think about aggregating preferences.
Okay, I'm following. So we've talked about prescriptive alignment. What about the backward alignment you mentioned earlier?
Right. So they also present a case for backward empirical alignment, but with a strong emphasis on transparency.
Transparency, okay. Why is that important?
Well, they point out that forward empirical alignment, where we train the AI on data beforehand, can lead to models that are like black boxes.
Black boxes.
Yeah, it's hard to understand why they make the decisions they do.
Right, they just spit out an answer, and we don't know how they got there.
Exactly. So they suggest using techniques from interpretable machine learning, or IML.
Interpretable machine learning, okay.
Yeah, the idea is that after the AI is deployed, we can actually look at its explanations for its behavior.
So we can see the AI's thought process.
In a way, yes.
Okay.
And then we can make changes based on whether it seems to be acting the way we intended.
So it's still empirical because we're observing how the AI behaves.
Right.
But it's more transparent because we can see why it's behaving that way.
Precisely. It allows for more fine-tuning and adjustments.
So it's like we're checking the AI's work, not just its final answer.
Exactly. And then they also discuss backward prescriptive alignment, using the example of how we choose decoding strategies for language models.
Okay, decoding strategies, what are those?
So language models, they're the AIs that can generate text, like write stories or answer questions.
Right, I've seen those.
And the decoding strategy is basically how the AI decides what words to generate next.
Okay, like the rules it follows to create text.
Exactly. There are prescriptive metrics that measure things like how coherent the text is, how diverse the vocabulary is.
So like, is it grammatically correct? Is it interesting to read? That kind of thing.
Exactly. And then there are empirical metrics, like one called MOUE.
MUUE.
Okay.
Which tries to measure how similar the AI's text is to human written text.
So, like, how good is it at imitating human writing?
Exactly. The paper highlights some findings from researchers who compared different decoding strategies.
And what did they find?
It was super interesting. One strategy, called XX, had higher scores on that MAUVE metric.
Meaning it was better at mimicking human text.
Yeah. But when they had humans actually read the text and rate it, they preferred the text generated by a different strategy called contrastive search. Oh, so the AI that was better at mimicking human text wasn't actually the one humans preferred.
Exactly. And contrastive search scored higher on a prescriptive metric called QText, which focuses on coherence and diversity.
So the AI that focused on following those predefined rules, those prescriptive metrics, actually produced texts that humans liked better.
Exactly. It's a great example of how purely empirical alignment might miss the mark.
Wow, that's a really important point. It's not just about imitating humans, it's about achieving something that humans value.
Absolutely. Now, the paper does touch on some other perspectives too, just briefly.
Okay, what are those?
They acknowledge the pro-forward empirical alignment view.
So those who think training on human data beforehand is still the best way to go.
Yeah. They often focus on getting good results on specific tasks.
Right, like if you just want the AI to follow instructions really well, then maybe empirical alignment is enough.
Exactly. They point to examples like InstructGPT and some work by Stianon, where training on human feedback has been really effective.
Okay, so it's not like empirical alignment is completely useless.
No, not at all. It's just that we need to be aware of its limitations.
Right.
They also briefly mentioned the case against alignment altogether.
Wow, really?
Yeah. This view argues that any form of alignment, whether it's empirical or prescriptive, could introduce human biases and might actually limit the AI's potential.
Interesting.
They point to examples like AlphaGo Zero, which became a master Go player without any human input.
Yeah, I remember hearing about that. It even came up with strategies that humans had never thought of before.
Exactly. So the argument is that by trying to make AI more human-like, we might be holding it back from seeing the world in new and potentially beneficial ways.
So alignment could be stifling creativity.
That's the idea. It raises the question of whether alignment should be about imitation or something more profound.
That's a deep question.
For sure.
Okay, so let's wrap things up. What are the main takeaways from this deep dive into AI alignment?
The key point is this. While aligning AI by observing humans sounds simple and intuitive, it comes with a lot of statistical risks.
Yeah.
We're basically trying to align AI with a whole population based on a potentially messed up sample.
Right, and that could lead to all sorts of biases.
Exactly. The AI might end up learning and even amplifying our own flaws and inconsistencies.
So it's not as straightforward as it seems.
Not at all. This paper really pushes us to think about alternatives, like prescriptive alignment, where we set clear rules and principles up front, and backward alignment, where we can look at the AI's reasoning and adjust things after it's already out there.
Right. So more transparency and control.
Precisely. These methods can help us avoid creating AI that's just a colorful imitation of us, as Wiener put it.
Yeah, we want AI that's aligned with our values, but not necessarily a carbon copy of us.
Exactly.
So it's not about giving up on alignment. It's about being smarter about how we approach it.
That's the perfect way to put it.
This has been a fascinating discussion. It really makes you think about the future of AI.
Yeah, for sure.
And it raises a really important question, and I think it's one for our listeners to ponder as well.
Okay, I like where this is going.
Given that we as humans have our own biases, and given that AI has the potential to become much more capable than us in many ways, what does truly aligned AI even look like?
That is the million-dollar question.
Are we trying to create an AI that perfectly reflects us with all our strengths and weaknesses? Or should we be aiming for something more?
It's a tough one.
How do we make sure that by aligning AI with human values, we're not limiting its potential to surpass us, to make discoveries that could benefit everyone?
Right. It's like, do we want AI to be our mirror image, or do we want it to help us see beyond our own reflections?
Exactly. Is alignment about imitation, or is it about something much bigger than that?
It's something we all need to keep thinking about.
For sure. This is a conversation that's only going to become more important as AI continues to evolve. And that's a wrap on this deep dive into AI alignment. Thanks for listening, everyone, and be sure to subscribe to the channel for more explorations like this.
And keep those brains buzzing.
We'll see you next time.